Hello, my name is Shreya Patel and I am part of the Vastvic team. We are developing an innovative algorithm that converts 2D images of wearable spectacles into 3D models. So, in this journey of converting 2D image of spectacles to 3D model, I first engaged myself in finding the data set of face images with spectacles along with their mask depicting the location of the spectacles. After this, I used the unit model for segmenting the spectacles from the original image with the output in binary form. Here it is shown the working of unit model. So here unit model, as the name suggests, in the shape of U, it consists of three structures. One is the encoder structure, then we have bottleneck structure, and then we have decoder structure. In encoder structure, we have convolution layers, uh, then along with the ReLU activation function, and we do max pooling as downsampling. And in the bottleneck region, we again have convolution layers. In decoder region, we upsample the image with the transpose convolution layers, and also we concatenate the output of the respective step of the encoder with the decoder's input image, and then we have the output in binary form. Here the classes would be 1 for the classification, and that's why we are getting black and white images. And the mask here used as for the optimization during training. So the model that I made for training in this data set and getting the output, segmented output of the spectacles, its accuracy on training data set and validation data set was 92%, and on test data set it was 97%, and I used BCE logits loss and Adam as optimizer. After getting the output in binary form, in order to retain the color of the spectacles from the original image, I applied bitwise NOT operation on the pixels related to the specs location. Then to generate the 3D model, we need to uh, generate the missing parts of the spectacles, the parts which are not visible after segmentation. So for that I use stable diffusion model. This process is called in painting. So this shows the working of stable diffusion model. Here we give inputs as prompt and the image, segmented image, and the mask, which shows the region where the model has to generate the missing parts of the spectacle. So here the prompt is goes to tokenizer, where it tokenizes the words of the prompt, and then the tokens goes to the text encoder, where it gets converted to text embeddings, and the image and the mask go to the image encoder, where they are converted to image embeddings, and both of these embeddings are stored in latent space. And then they are uh, they go to UNet model, which also takes random noise and guidance scale. So what UNet model does is, with the help of the embeddings, text embeddings and image embeddings, and the guidance scale, it takes input the random noise and remove the extra noise from the image, and it does this repeatedly and after upscaling we get the resultant image as shown here. Now after getting the complete image of the spectacle, I need to denoise the resultant image because the stable diffusion model that I used here, it is a pre-trained one named as runway stable diffusion model from Hugging Face. So this model does not always give a clear cut complete image of the spectacle, so I need to denoise some of the images, and I manually made the mask of the images. So I made um, 30 masks for the images. So here the number of images are less for the training of the 3D model algorithms. So to increase the length of the data set, I need to use synthetic augmentation, and then I'll apply 3D model conversion algorithm, which is yet to be done. I'm currently at denoising the resultant images.